Hi, now I want to solve a problem which is given a list of n minus 1 integers ranging from 1 to n, there are no duplicates in this list, but an integer is missing in this list. So our problem is to find that missing integer. So to understand this problem statement more clearly, let's take an example. So this is our array which has elements ranging from, we know that the elements will start from 1 and 1 to n, so we have to find out what that n is. So the in this case n is 8 because 5 is the missing number, so obviously 8 is the greatest. So uh, in this case n is equal to 8, and there are n minus 1 elements, that is there are 7 elements in the list, 3, 6 and 7. So uh, so we have to find that 5 is missing. So how do we actually find that 5 is missing instead of just looking at the numbers? Say what if the array is big enough and we don't know, like we can't, if the array is like, if the size, if n is 1000, then you can't keep looking at 1000 numbers and say that okay, this number is missing. So there should be an alternative way of finding it by program, right? So um, to start with, there are two approaches, but to start with, like we know that the range of numbers is 1 to n. So the first solution that comes into my mind is finding the summation of these numbers and finding the sum of these numbers and then subtracting these two will give me the missing number. Like what I'm trying to say is my n is 8, so I'll find the sum of there is a formula to find the sum of n numbers, that is n into n plus 1 by 2, like 8 into 8 plus 1 by 2 is 36. This is my sum of n numbers, but I want to find the sum of this array, so I'll loop through the array and find the sum. So here in this case 10, 20, 30, 31. So my sum is 31. So when I subtract these two, I get 5. So 5 is my missing number. So this is the solution, this is the basic solution that comes into mind when this is the default conditions that we have. But this solution is problematic if if n is large, because we have to there is a range where you can integer also has a range, but if n is very large there could be a overflow that can occur. So that is the reason, instead of doing this approach, I have a better way of solving this problem. So what we can do is we can um, 1, 2, 3, 4, 5, 6, 7, 8. So we know this is 1 to n, and this is our array 1, 2, 4, 6, 3, 7, 8. So this is my array. So all I was trying to do here is taking the sum of this, and like say the sum of this is x and sum of this is y, I'm doing x minus y. So instead of taking the sum of the entire array, what difference, sum of the difference of the entire array, I'll subtract these two numbers, 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 these two, and add the result of these. Like 1 minus 1 is 0, plus 2 minus uh, 2 minus 2 is 0, plus 3 uh, 3 minus 4 is minus 1, 4 minus 6 is minus 2, 5 minus 3 is 2, 6 minus 7 is minus 1, 7 minus 8 is minus 1, and then we have 8. So when we add all these, it is minus 3 plus 2 minus 2 plus 8. So this get cancels. 8 minus 3 is 5. See, we got the answer 5 even using this method, but we are avoiding the integer overflow with this approach. The same thing is implemented here. Like I could go through the solution. So for the function find missing integer, we are taking array as the input and we are taking n as the another input parameter, where n is the range n, where n is the range, because that is the given data. So first thing is I check whether array is null, or that length is we have an empty array or not. In that case I'll return. And but in our case we have a valid array, so we'll go ahead with our logic where I'll start my array with, because we have a range of numbers from 1 to n and we have to start subtracting these 1 to n with the given array. So I'm taking the loop from 1 to n. Okay, but because one element is missing, so I'll match the number of loops to the number of elements. That is, the condition holds good for n minus 1, same number of elements in the given array. So when let's trace this. When I is I and sum, so when I is 1, my sum is initially 0, so 0 plus I is 1, array of I minus 1. I minus 1 is 0, that is 1, that is minus 1, so your sum is 0 here. Next time when I is 2, it is 0 plus sum plus 2 minus 2. This is also 0 here, so my I is 3. This sum is 0 plus I minus array of 3 minus 1 is 2, that is 4. Now my sum is minus 1. I is incremented to 4. So this loop is valid till 6. I mean I is 6. Okay, so it is minus 1 plus 4 minus 6. So this is minus 9 plus 4 is minus 3. Okay, and now I value is 5, minus 3 plus 5, and the fourth index value is 3. So I am doing this minus, that is, it gives me minus 1. Now I value is 6. 6 is less than, what is n? N is 8, right? 6 is less than 8, that's true. So I will go till minus 1 plus 6 minus 7. 6 minus 1, array of 6 minus 1 is 5, that is 7. So minus 8 plus 6 is minus 2. Okay, now I value is 7. Is 7 less than 8? True. So minus 2 plus 7 minus 8. So my answer is minus 10 plus 7 is minus 3. Okay, this is minus 3. Now I value is incremented to 8. Is 8 less than 8? No. It will come back and return sum plus n. My sum is minus 3 and my n is 8. Like I said, it is 8. So that is 5. So I'm returning my missing number back to the calling function. So this is how a missing integer. For this problem, the complexity is because the range of numbers is we have only n minus 1 things. The complexity is O of n minus 1, or you could say the length size of the length of the array. length of array. Instead of n, we could say length of array, or O of n minus 1. This is the time complexity, and we are not using any additional space, so space complexity is O of 1. So this is my efficient solution. Thank you.